Well, good afternoon from a rather damp London, and a warm welcome to all our participants wherever you are in the world. And an especially warm welcome to our speaker, Dr. Sandra Bour-Schaeffer, who is head of Airbus Group Demonstrators and the CEO of Airbus UpNext, about whom more in a moment. My name is Brian Burridge, and I'm the Chief Exec of the Royal Aeronautical Society. It's a great pleasure to introduce Dr. Sandra Bour-Schaeffer, who's got probably one of the best jobs in aerospace. As CEO of the Airbus UpNext business, she gets to trawl the best talent and seek to accelerate disruptive technologies to the demonstrator level as quickly as possible. It was this approach that saw the scale model of Maverick unveiled at this year's Singapore Air Show, with its innovative blended wing fuselage, allowing huge possibilities in payload and in novel propulsion. Now, the climate change challenge is very real, perhaps nowhere more so than in aviation, particularly because increasing global regulation, ethical considerations, and indeed in the UK, the legal requirement to be at net zero by 2050. In terms of the life cycles in aerospace, 2050 is very close. Closer still is the Airbus target to launch a zero-carbon airliner by 2035. And while it's clear that technology alone cannot achieve the zero-carbon goal, it will nevertheless be a major contributor, and one that will require considerable investment and access to expertise that may currently lie beyond the major manufacturers or indeed beyond the sector. But the aviation crisis resulting from COVID-19 might ultimately place a question mark over investment, and supply chains have been very severely disrupted, putting at risk potentially those nascent technologies that will be vital in reaching our 2050 goal. Now, there's no one better placed to help us understand those challenges than Dr. Bour-Schaeffer. Over to you, Sandra.
Thank you very much, Sir Brian. Thank you so much for this warm welcome. I'm delighted to be able to join you this afternoon, and I'm excited to provide an update on Airbus' sustainable aviation ambitions. We've all been hit hard by the health crisis in the past year or half year. Our thoughts, of course, with everyone who has been personally impacted by this pandemic. And as you can see on the slide here, the aviation sector has not been immune. It has suffered from an unprecedented hold and is still struggling to recover. Worldwide domestic flights have been down 70% for months on end. And here in Europe, the largest regional airports are managing 90% fewer flights. Incidentally, the ripple effect created by this slump in air traffic is severely impacting the global economy. The aviation industry's contribution to the worldwide GDP alone is a staggering $2.7 trillion. So you can understand why we at Airbus have been focused on supporting our entire aviation ecosystem to ensure our industry stays afloat. There is obviously the obvious question you're asking, is aviation still committed to climate action in a post-pandemic world? Or will it focus on restoring profitability again as it recovers from the gravest crisis to hit the industry? I'll be very, very candid with you. Preserving our climate and the environment is the indispensable foundation upon which to build the future of aviation. Ecologically and economically, societally and politically. The corona crisis has only served to accelerate the urgency. We firmly believe there won't be any industry profit without climate protection. And at Airbus, we are not only remaining committed when it comes to flying carbon neutral in the decades to come, but we have accelerated our ambition into a tangible plan to bring, as you said, zero-emission aircraft to market by 2035. Indeed, for our industry, there is no single solution to decarbonizing the skies. Multiple technology pathways are required, including continuing to push forward with the production and uptake of sustainable aviation fuels. Our work in electric flight and hydrogen fuel cells is laying the groundwork for future climate-neutral, zero-emission commercial aircraft, as has the extensive research and development work that we have been pressing ahead with over the last 2 decades in the field of zero-emission flight. We have successfully flown our Vahana demonstrator and played a pioneering role in maturing eVTOL concepts for urban air mobility. Our 4-seater City Airbus eVTOL is currently undergoing flight testing in Germany and will further advance the aviation industry's knowledge in the field of fully electric, zero-emission vertical takeoff and landing vehicles. Our EFA-Next project helped us to learn more about serial hybrid propulsion architectures and other technology breaks which are indispensable to make our future zero-emission commercial aircraft a reality. As you can see, Airbus is already actively engaged in the development of new technologies and materials, as well as improved operations and more efficient infrastructures. One particular technology pathway we have been exploring and find extremely promising is hydrogen. This afternoon, I will show you the 3 concept planes that are helping us as a company to project the use of hydrogen on aircraft. I'll explain what we are investigating, where the challenges are, and finally, how we need to address them together across the entire ecosystem. And this is very important. It is about a collaborative work. So indeed, hydrogen has emerged as a clear game changer because it ticks all the right boxes. It's safe, versatile, lightweight, and storable as either compressed gas or liquid. It has a high energy density that is nearly 3 times superior to jet fuel. Most importantly, hydrogen emits no CO2 emissions when burned. Water and vapor are the only byproducts when fuel cells are used. This fact alone solidifies hydrogen's reputation as an exciting zero-emission technology pathway. In fact, hydrogen is already part of the solution for climate-neutral targets for several industries, not just aviation. This means that the cost of the production and distribution associated with sustainable hydrogen across global industries will continue to decrease, making hydrogen economically feasible for aviation applications. According to a study produced this year by McKinsey for the European Commission, liquid hydrogen will drop from 4 times the cost of kerosene today to roughly the same cost by 2050 as kerosene, obviously. This does not mean that there are no challenges ahead. Yes, challenges remain, namely the availability of green hydrogen and the challenges associated with bringing these new propulsion systems up to airworthiness and regulatory standards, which are precisely the topics we will explore at the company together with our industry partners in order to field a first zero-emission aircraft by 2035. In September, Airbus revealed 3 concepts representing different approaches to achieving zero-emission flight by 2035. Exploring various technology pathways and aerodynamic configurations. All 3 zero-E concepts, this is how we have named them, and you can see them here on the slides, rely on hydrogen as the primary power source. Indeed, we estimate that hydrogen could contribute over 50% to our journey towards climate-neutral flight, allowing for mobility to continue serving the fundamental needs of human connection, societal bonds, and economic progress, in a way that is in better harmony with the environment, so that future generations can enjoy flying as much as we do it today. The 3 concepts include a turboprop design with a capacity of up to 100 packs powered by hydrogen, rather than fuel as of today. The target range of this concept aircraft is in excess of 1,000 nautical miles, making it a perfect option for short-haul trips. We have also introduced a turbofan design. This would carry between 120 and 200 passengers with a turbofan engine instead of a turboprop as previously, always powered by hydrogen combustion in modified gas turbine engines. And the range would be over 2,000 nautical miles roughly. And we have introduced a third concept, which is our blended wing. So Brian, you mentioned Maverick earlier. This is exactly something we could build up on our Maverick demonstrator. A wide cabin layout, which opens up multiple options for hydrogen storage and distribution. For the moment, we're pursuing the idea of cryogenic storage tanks. Passenger capacity and range for this one are the same as for our single-aisle concept. So all three zero-E aircrafts are exciting concepts, and each one of them offer a lot of advantages for future air travel. They all rely on hydrogen in one way or another. That's why I'd like to go with you a bit more into the detail to let us explore how hydrogen can play a role in decarbonizing the aviation industry. In general, there are three predominant ways of using hydrogen for aviation. The first one would be as a sustainable aviation fuel. Hydrogen can be used to create synthetic fuels, which are drop-in fuels and combine essentially CO2 with hydrogen. They are often called e-fuels because of the electrolysis, which is used to generate the hydrogen from water. The missing CO2 component is ideally sourced from industrial waste streams or carbon capture system. The second way would be to use hydrogen and combust it through modified gas turbine engines, leaving essentially water behind. And a third way would be to use this hydrogen to convert it into electrical power via fuel cells. Those later two options call for liquid hydrogen storage capabilities. Why is that? Well, hydrogen has an energy density per unit mass that is 3 times higher than traditional jet fuel. This is great news, as it means that our transported energy source weighs less. Unfortunately, there is also a lower energy density per unit of volume. Therefore, we need to consider taking liquid hydrogen on board to keep the volume down. And the fact is that hydrogen gas turns into liquid when it is cooled at a temperature below minus 253 degrees Celsius or minus 423 degrees Fahrenheit. So we are confronted with a great challenge of finding a way to bring this cool hydrogen into a liquid state and keep it on board. This brings it to the second question of what does it mean to safely store hydrogen, liquid hydrogen on board? And this is where our concept play a role. They help us to address those questions. And just as a reminder, concept planes are not new aircraft programs. They are not even demonstrators. They are really concepts on which our engineers build to learn the integration of different technologies. For example, they ask themselves the question of where to store this high-pressure liquefied supercooled hydrogen. Indeed, many liquid hydrogen aircraft designs incorporated in the fuselage, leading to increased fuselage length and maybe diameter in comparison with conventional kerosene-fueled aircraft that we see flying today. A keen eye has maybe spotted that there are no windows in the area behind the rear pressure bulkhead on our renderings. Classical fuselage concept could rely on tank storage just behind the last passenger seating row. However, as you know, strutting the fuselage has a weight effect, but also causes the net wetted area to grow, changing the overall aircraft aerodynamics and flight mechanics. All in all, this results in a snowballing effect with impact on the overall performance. You may have seen, for instance, on the turbofan version, a very large wingspan. These are just examples helping to explain that we need to improve the overall aircraft itself in order to mitigate some of the effects of new energy sources. And this is again where the concept planes help us. Through these studies, we continuously push the borders of the technical feasibility, breaking ground on the yet unexplored savings territories. This allows us then to benefit from those savings to find the global optimum for this configuration. So as you see, we aren't limiting ourselves to conventional configurations. We're also looking, for instance, at the flying wing concept and what it has to offer in a context of zero-emission technologies. So it's really about looking not only at the propulsion sources, but at its whole integration into an aircraft. And assuming we have found a way to safely and efficiently store our cool propellant, what do we then do with it? Well, we first of all have to safely transport it from the tank to its next destination in the power generation system. This can be an engine able to burn gaseous hydrogen, or it can be a fuel cell making use of the hydrogen to create electricity. Both technologies are yet to be developed for this type of application. For example, for the direct hydrogen burn concept, which might sound actually appealingly simple, we will not be able to accommodate hydrogen combustion without technology development on the gas turbine, modifying injection and modifying combustion chamber, for which we will need the collaboration and buy-in of our engine manufacturers. You have understood it. The challenge of the propellant or the new energy sources is never a monodisciplinary trade, and we are eager to leverage all the experiences we and our vast partnership network have developed since the beginning of Airbus. We will only be able to make it all together. So you might want to ask, which of those is the best concept? I would say that every concept has a purpose, a potential market, a technological focus, and also a time frame associated. And this again brings us back to the fact that there is no single answer today, only learnings and lots thereof. In a nutshell, over the next few years, we will refine each concept to make sure we have matured the technology enough to deliver on our zero-emission ambition. Supporting this ambition in order to evaluate, mature, and validate these new technological pathways as viable future products, we are considering several hydrogen flight demonstrators, which we hope we will be able to announce formally over the coming months. These flight demonstrators will be a key part of our ambition to mature the technology by mid of this decade, when we will have to make technology choices to allow product launch decisions. This is where Airbus Group Demonstrators and my own Airbus UpNext organization really have their role to play. At the center of innovation for Airbus, this is an environment in which we incubate promising technologies, rapidly proving their feasibility in scaled applications before handing them over to the pre-industrial manufacturing and infrastructure divisions. In other words, we are literally building the future of sustainable aviation. And Brian, you're right, this is really a cool job and probably one of the best ones I could imagine. We have unique possibilities to engage with our internal R&D experts, as well as external partners, pushing the boundaries of industry-wide collaboration to make research become reality. And it is well understood that the new competences of tomorrow's aviation will very likely also come from industries and areas of research outside of aerospace, and solving those skills are a central part of our mission. We see hydrogen as one of the most promising solutions that could contribute more than 50% towards meeting our climate neutral targets, strengthening Europe's long-term competitiveness and its ability to address global emission reductions. However, beyond the technology challenges, the aviation industry's transition to renewable hydrogen will require the regulatory and infrastructure ecosystem to change. We have already started working with energy suppliers, infrastructure providers, airports, and we have several memorandums of understanding with several airlines to develop the ecosystem in parallel to the aircraft and its technologies. Airports will require significant hydrogen transport and refueling infrastructure to meet the needs of day-to-day operations. The major advantage with hydrogen is that it can complement existing refueling options at most major airports. Decarbonization of airport and adjacent ground transport equipment like heavy-duty logistics, buses, tow trucks need to start in the 2020-2030 timeframe to start familiarization and scale-up of hydrogen at airports. Some airports like Toulouse have started on this journey already. This will bring hydrogen to airports in the next few years and will start to prepare the ground for scaling up from when we need it in the early 2030s. Converting existing oil and gas transport networks to make them suitable for hydrogen is also a promising option in this respect. Cross-industry collaboration will be required to drive down infrastructure and production costs. And this huge scale-up means that we get an environmental benefit which will be mutually beneficial and speed up development of the hydrogen economy. We must therefore continue to push forward with the production and offtake of sustainable aviation fuels, which are an integral part of an aviation decarbonization strategy. And in the short term, the best way to reduce emissions, of course, is to create a green stimulus by creating the right conditions and financing support to allow airlines to retire older, less environmentally friendly aircraft early. We need support from the UK and our other states in these ambitious objectives, with increased funding for R&D, digitalization, and incentive mechanism or regulations encouraging the use of sustainable fuels and the renewal of today's aircraft fleet. We will only succeed if all industries choose a pathway towards the Paris Agreement, so collectively we can scale up renewable energy and hydrogen at a massive scale. Hydrogen, also only part of the solution, is a very promising technology pathway for aviation. This is here to stay for the long haul. So to sum up, we really feel that this is a historic moment for the commercial aviation sector as a whole, and we want to play our part in the most important transition this industry has ever seen. The concepts we have unveiled offer a glimpse of our ambition to drive a bold vision for the future of zero-emission flight. That will help us explore and mature the design and layout of what we hope will be the world's first climate-neutral zero-emission commercial aircraft, which we aim to put into service by 2035. We strongly believe that the use of hydrogen, both in synthetic fuels and as a primary power source for commercial aircraft, has the potential to significantly reduce aviation's climate impact. And it will be complemented by a variety of technology pathways to enable reaching emissions reductions by 2030 and achieving carbon neutrality by 2050 as set out in the EU's Green Deal. Together with the support of governments and industrial partners, we can raise up to this challenge to scale up renewable energy and hydrogen for the sustainable future of the aviation industry. Thank you so much for listening. I'm very happy to take any questions you might have.
Well, thank you very much, Sandra. That was both fascinating and an absolute benchmarking clarity. There are a number of questions. What I'll try to do is develop them into themes. First question really goes back to the whole theory of protection from greenhouse gas and the notion of actual zero emissions, in that there is obviously concern about other types of emissions than purely carbon, and I'm thinking of particularly contrails and aviation-induced cloudiness. So with a hydrogen-powered turbofan, you're pushing water into the atmosphere. So the question is, so what are the differences in amounts of those sorts of emissions are there between a hydrogen-powered engine and a conventional engine?
Well, clearly the emissions of the traditional engine come today with CO2, which is our biggest concern. They come with NOx, which is also something we need to be very careful of. And if we go to a transition to sustainable aviation fuel with hydrogen, for example, we will be reducing net globally the CO2 emissions, and we will probably also have an impact on the NOx. If we now consider hydrogen in a usage on fuel cells, for example, then we get completely rid of CO2 emissions. But as you clearly stated, we will be producing more vapor and probably more contrails. So as I said, there's no crystal ball. We have not one single technology. We need to understand all these impacts on the overall climate, on the overall layout of the different technologies to be able to make the right choice at a given point in time. But yes, there are open questions which remain and we have to look into, and contrails are one of them.
Yes, and of course it's entirely plausible to avoid contrails by flying at different heights, but that's never actually been embraced in air traffic management, at least not yet, though I'm sure it will be. The next question is about engines. We've heard obviously quite a lot from engine OEMs over the years about the incremental improvements they're making and changing to things like ceramic blades, etc., very high bypass ratios. But we haven't heard much about what they're doing in order to optimize engines for hydrogen use. Can you say something about that? What are the engine OEMs with you on this?
Well, as I said, if we transition to hydrogen, it can only be a global industry decision. So we are discussing with all our partners, our engine manufacturers, to see what roadmap we can drive. We are intentionally giving a push there because we, as Airbus, have said that climate neutrality is very important. We have a very ambitious target by launching zero-emission aircraft by 2035. And this is also an appeal to the whole industry to go with us on this road. And clearly, it means that we will continue engaging, as we have done over the past decades, with our partners, with the engine manufacturers, to build up a roadmap that is feasible. And again, depending on what type of product you're looking to, you will not have the same kind of solutions for an eVTOL, which could fly on batteries, for regional aircraft, and for long-haul aircraft. So clearly, if we go to the extreme of the long-haul aircraft, I do believe that our today engines will still be quite similar to what they are, but we need to optimize them for synthetic fuels, for example, which could be one pathway, and other options we need to explore together with the engine manufacturers. So depending on what type of product you're looking at, there will be different answers, and all of them come with an ecosystem which we are willing to push in together and drive together to come to that climate ambition and this neutrality.
And are you seeing any new entrants coming up with novel ideas about engines, people we haven't heard of in the sphere before?
Nothing I could, on the top of my head. I think we have a wide ecosystem which works well, which has been working together over the past decades. We really want to continue on that collaboration. But we also need to be open to see what other technologies might pop up and see how, as a global aviation industry, we can actually benefit from what has been developed in other industries to bring it on board to our aviation industry and make it certifiable to aviation rules.
Yeah, I'd like to come back to that in a minute. But first, You mentioned particularly the developments in what are relatively large aircraft, some very large, but what about the other end of the scale? What's the feasibility of using hydrogen, probably from fuel cells, for in direct combustion at smaller scale, like in helicopters, EC-135, or a rotary drone?
Indeed, I started with examples like Bahana or City Airbus on purpose to put on the table the whole range of products the aviation industry is looking at. And for each of these products, there will be different solutions. Some of them can be fully electric, relying mostly on batteries. Some of them could look at the use of hydrogen on small helicopters indeed. And there probably the way to carry the hydrogen will be different from the solution you choose on a long-haul aircraft. So gaseous hydrogen could be an option on a helicopter, which is a totally different integration to the one of the long-haul aircrafts, basically. So yes, we look at the whole scale, and there will be different solutions according to what product we are targeting, what range we are targeting, what weight, what autonomy we are looking at.
Thanks. And could you say something about the broader industry, trains, buses, etc.? How will they develop, and what will the impact of their development mean to the overall infrastructure for producing, transporting, and bringing hydrogen to the point of use?
I think clearly hydrogen is appealing to many industries today. Only if there's a global push for it, we will come down to the numbers McKinsey have forecasted in their report, where hydrogen gets to an affordability level which is comparable to kerosene by 2050. So aviation industry on its own will probably not be able to drive this reduction in cost and infrastructure, and there must be a need from other partners. But I see willingness from different industries to look at hydrogen and integrate them in their path to climate neutrality as well.
Okay, and if we can just turn now to the mix of novel fuels, because the UK's own climate change committee posited that forget electrification, use synthetic aviation fuels, and they didn't really talk about hydrogen in their latest report very much. But given that potentially synthetic fuels, which are here, biofuels are here now, e-fuels a little bit further away, considerable investment required, but is there a danger, and most people think that there will be a sort of staged introduction of each of these things, and probably will arrive at 2050 with a combination of them all. But is there a danger that governments in particular, in determining their research and development investment assistance, will be beguiled by hydrogen, say, instead of SAF or instead of electrification?
Well, as much as I do believe that hydrogen is very promising, I also said that we could imagine that it could contribute up to 50% of our target to reduce our climate impact and come to carbon neutrality in 2050, which means there are still other 50% to investigate. So yes, I think it is a route to investigate. I think there is a push needed there from the regulatory, from the governments to really explore that way. But I also do believe that we need to keep other technologies alive, because there will only be a combination of solutions to bring up there. And again, depending on what type of product you're talking about, the solution will again be different. So we need to keep our eyes wide open, and we need to integrate and mature the different relevant technologies for the different products on different time scales to actually meet this ambition.
Thank you. On to the dreaded subject of taxation, and aviation is beset by taxation strategies in order to move it in particular directions. And is it possible, given currently the projected cost of hydrogen maybe 3 to 4 times that of kerosene. Would you support lobbying for a significant carbon tax to come in order, if you like, to level the playing field?
Well, I think there's no silver bullet to decarbonize our industry. Zero emission credit, or what we call CO2 emissions compensation schemes, will probably be needed as a temporary solution until these disruptive solutions reach maturity. This is why, as Airbus, we continue to support ICAO's CORSIA for offsetting and mitigation aviation CO2 emissions, and the EU emission trade scheme, which will have a role to play in bridging the transition to this sustainable solutions indeed.
And you mentioned the need to tap into the whole ecosystem in terms of developing your concepts. Could you just say more about a bit more about SME involvement and the degree to which you absorb them in your strategy? Because certainly here in the UK, we've seen a number of SMEs developing hydrogen solutions, and it may be that they will be able, as one in particular, ZeroAvia, who may be in a position to produce a 20-seater very quickly.
We are talking with many companies out there, and this is also one of the assets we have with Airbus UpNext, which is really able to leverage on different partnerships beyond the classical partners we have been working with and we will be continue working with. We are looking at startups, we're looking at research institutes, we are looking at SMEs who have options to offer or willing to go on that route to see what is the potential behind it. So we are not yet at a product development, but we are very keen on talking to those partners and see how we can actually embed them in our development to mature those technologies, to then be able to choose technologies and then a second stage be able to launch a product. So clearly, to me, they are an essential part of the ecosystem. And the other thing, or the other component whom are essential as well, is the industry which is not directly related to aerospace so far. There have been several developments in car industry and others, which are definitely not, you cannot copy paste one by one into our industry, but still there are food for thought and exchanges there we would like to further work on, to really be able to make those difficult choices, because it really is a revolution for aerospace. We are on the edge of building a totally different environment, with this climate neutrality being really at the heart of our choices. And it means that we have to open up to all possible solutions there. And we are very happy to collaborate with everyone who has something to bring into that bigger picture.
And is it your sense that there are particular nations in the lead here, US, China?
Sorry, I didn't hear the start of the question.
Are there other nations who you regard as being in a leadership position? I was thinking, obviously, two big aerospace nations like the US and like China.
I think Europe has been pushing very hard. We really have said with the Paris agreements, but also with the global politics in Europe, a clear target of being carbon neutral by 2050. We are continuing on that ambition. We're saying we want to bring an aircraft to the market by 2035. So there's a push in Europe, but I'm convinced that our partners in the US and in China are also working on this big subject, which will make the difference in aviation in the years to come.
And a small, short, but technical question. Can hydrogen be generated on site at an airport? I mean, is that part of the concept? Through electrolysis, with obviously waste heat being generated, which can be used for all sorts of purposes in heating buildings.
Yes, indeed. Many regional initiatives already exist. For example, the airport here in Toulouse is planning to break ground this year for a hydrogen production and distribution station, making hydrogen available for airport shuttles and private passenger vehicles. So clearly, we are not at the scale we would need for an airplane, but it's starting there. And thanks to funding from regional and national projects, this supports really the Horizon Europe ambition and the push for hydrogen.
Okay, thanks. It goes without saying, in the society we have an aerodynamics specialist group, so I'm sorry about this question, but we are used to dealing with wing bending moment on traditional aeroplanes by moving the fuel around in a particular way. Equally, we spend a lot of time on aeroacoustics and understanding the noise footprints, etc. How do those two things apply to a hydrogen-powered airplane?
Well, clearly, if we go, and this is not decided yet, this is part of the concept airplanes to learn about it, but if we go for storage of hydrogen, for example, in the fuselage, we have no longer the wetted wings as we used to have them today, which have an influence on flutter, which have an influence on our acoustics, etc. So all of that we need to understand to see what would be the design of tomorrow. And therefore, it is equally important to work on the propulsion system, on the primary power source, if you wish, as it is important to work on wing design. And I didn't say much about it, but I mentioned that on the turbofan, the wing design is different from what we had up to now. And this is clearly areas where we also put a strong focus on to be able to come to an overall optimum. And the overall optimum will be different from the one we have been using to work with up to today.
Right. I was expecting the next question, and it's taken a while to come up, but perhaps predictably it's come from a lawyer. In terms of hydrogen, do you in Airbus perceive that there will be a risk of either passenger resistance or any other resistance to hydrogen fueling, given the airship experience in the 1930s? And so, if so, how will you approach that?
I didn't emphasize on it, and it's very good that actually the question has been raised, because safety is the priority for the aerospace industry. We have been able, with all our partners, to make airplanes safer and safer and safer over the decades to come. And this is the key parameter which will never change. And this is true for hydrogen, but it's also true for eVTOLs. If you talk about flying taxi, one of the challenges will be to have those vehicles at the same safety standards as of today. So there is absolutely no question about compromise on safety, and we have to deal with hydrogen. And today we do believe that it is feasible. There are constraints, there are challenges, we need to work on it, but overall it seems feasible. But again, this will be part of the work to be absolutely sure that safety is not impinged in any way with the use of those new power sources.
And I suppose related to that, part of the answer is sort of building up the confidence and, dare I say, educating the regulators. So what discussions have you had so far with EASA or any of the other regulators?
So we are in regular exchanges with EASA on this different and FAA on this different subjects. It was the case for UpNext, for example, where we were pushing the boundaries of batteries. It's the same thing today with hydrogen, because you're right. We need to build the certification frame to actually be able to deliver those concepts. And the same thing again is true for eVTOL, where if we have a fully automated vehicle, we need to define what regulatory rules do we have to certify it, and therefore we need to build them together with our partners EASA and FAA and the other regulatory bodies across the world. So it's also there a partnership. I think I tried to emphasize it during the speech. What is important today is that this transition cannot happen with a single player. It really needs an ecosystem. It needs our partners, it needs the SME, it needs our traditional partners, it needs regulatory bodies, and it needs politicians. We all need together to strive for this ambition of climate neutral aviation. Otherwise, we will not be able to make it.
And as you pointed out, and as we can see, we're now in 2020, airplane flying potentially in service after 2035, and 2050 isn't very far away. But in the lifetime of a single career, it's quite a long time. So, how do you anticipate the skills that you will require will change in your workforce from now to 2050?
Clearly, we see that the skills will be slightly adapted. Some of them will remain because we will still need aeroacoustics, we still need aerodynamics people, we still need people able to do flutter systems, etc. So a core of what the aviation industry is today will remain as it is. In addition, we will have to add skills, for example, on hydrogen, but also on other technologies. What will be the future of batteries? What will be the future of sustainable aviation fuels? How do we bring all of that together? So this is again what we try to do here at Airbus UpNext, where we have a mixture between 60% of people coming from the classical Airbus environment, if you wish, being able to make the bridge back to this mothership, and 40% of our skills coming from different areas, which really bring a different point of view and different knowledge and add it to the knowledge the aerospace industry has gathered over the years to come.
And we're already seeing the requirement for an influx of data scientists and people with a deep digital background, which of course is not totally new, but in volume relatively a relatively recent phenomenon. So presumably chemistry graduates will start to show themselves in the aerospace sector.
Exactly.
Which is great. I mean, the wider our appeal becomes for STEM educated graduates, the better. But how difficult do you think it will be to attract young people into this industry? IATA published figures only today on the current state of the industry. Is it possible to show them the vision of what the future will be like? Because if it's exciting, if it's glamorous, ethically well aligned, then I think we stand a chance. What's your view on that?
I fully share it, and this is also part of this concept airplanes and our ambition to clearly state we have an objective by 2035. Yes, it's challenging. Yes, it's difficult. Yes, there are many questions out there to be able to reach it. But we are at the fourth revolution of the aviation industry, and it's now more than ever the time to participate into that great adventure to make sure that aerospace still stays there for the future generation, able to connect us, able to make a global world out of it. So I am convinced about aerospace. I've been working in aerospace for more than 20 years, flying on all our airplanes. I believe it was already exciting, but I see we are really at the start of something new where we will integrate different skills. You talked about chemistry, but we could also talk about image processing. Never image processing has been so close to our concerns as it is today. So we're really exploring new pathways to make that experience of aviation exciting for the passengers, but also climate conscious and climate neutral in the years to come. So I can only encourage the younger generations to go outside, have a look at aerospace, and see how amazing it is actually to be able to sit on the runway and see an aircraft taking off for the very first time, the aircraft you have really put all your energy, heart and soul in it. It's really fascinating, and I hope that many will be able to join us in this adventure.
Absolutely, and of course it's a very live issue at the moment, and we find that in the society in our careers advice. Just on the matter of investment, and it's clear that two big OEMs like ourselves and Boeing would have had a strategy a few years ago pointing in the direction of decarbonisation. But what about raising capital on the markets? At what point will this be attractive enough to bring in big investment from major investors?
That's actually a very good question. It's something we need to explore. We need to explore it for new concepts as eVTOLs, and you can see there are many companies popping out there in the outside world which are actually trying to get to flying taxis and be able to gather a huge financing effort from the market. On our side, I believe we also have to keep this opportunity open. We have to answer the questions on technologies. We have put ourselves a very big target, but this is something we can investigate, and having this bold move of saying we want to decarbonize the industry, this is our roadmap, this is how we make it happen. Discussions can probably also start on this financial point of view.
Thank you. And there was one more question, just forgive me. No, I think I've already asked that one. Thank you very much. We've ranged over a large number of questions, and I'm really grateful for the clarity of your answers, the depth you went into your presentation. And there is, I guess, three things that stick in the mind. One is, as you said, this is a multifaceted approach. This is going to require the coordinated effort, investment, energy of perhaps a wider ecosystem than we're used to. Secondly, I guess the whole of the transport system and ecosystem is going to be concerned with how you generate, how you store, how you distribute hydrogen. So it's not as though in a way we're ploughing our own funnel. And lastly, of course, it's self-evident that without this level of effort, we will not get to the point where we are decarbonising and meeting the Paris Accord targets and those things that are really, really important for the benefit of our planet. So thank you very much for that. And we are next, or first of all, I must ask the patient attendees if they wouldn't mind completing the post-webinar feedback form, because that gives you a chance also to input to the programme for 2021, which this very week we are beginning to mould into shape. So I'd be grateful if you do that. Secondly, we have two more webinars in this series before the end of the year, both very topical. On the 30th of November, Professor Sir Charles Bean, London School of Economics, also the Office of Budget Responsibility, will talk about COVID, Brexit, and the UK's economic prospects. Very interesting. We timed it so that it would happen after the budget, which we now know we're not going to have, but I'm reliably informed we will have a comprehensive spending review, or at least a spending review. And then a little later on in December, Professor Mike Clark going to talk about the Integrated Defence and Security Review, which is going to be published at the end of November so far. He's entitled his talk as Grasping or Missing Generational Change. Mike is a great acerbic commentator on government policy. So put those in your diary, please. And in addition to the corporate partner briefs, and very much related to this, we have obviously a number of virtual conferences on our own proper commercial platform, which is much more like a TV station than a webinar. But the major aspect of interest is our climate change conference coming up on the 3rd, 4th of November over 2 days, 2 short days, you'll be glad to know. It has a very, very good list of participants and is founded on our Greener by Design group, which some will know has been going for 20 years, and in the year 2000, 2050 seemed a long way away. It doesn't look that way anymore, but these are really popular conferences, and the annual Greener by Design report is widely read. So tickets are available, so go onto the website and you can book for that, or indeed, if you email the corporate partner team, they will do it for you. So it just remains for me again to thank Sandra very much indeed for an excellent presentation. Thank you all for attending, and in the tradition of these things, I wave a regal goodbye, and everything will shortly go dead.
Thank you.